This is Projectile Motion 3, More Motion at an Angle, Cannonballs 2, a worked example. Kim the kangaroo is hopping along over alligators with a speed of 7 meters per second. The alligators are spaced 3.2 meters apart, and Kim takes 0.5 seconds to go from alligator to alligator. At what angle must Kim make each of her jumps? Presumably to avoid getting eaten by the alligators. Okay, this is an unusual one. We haven't done this type before, which is why we're looking at it as a worked example. So the first thing we'll do is draw a picture of it to visualize. So we got the ground there, and we're going to draw in alligators represented by the purple bumps. So we have 3 alligators. The alligators are a distance apart of 3.2 meters. And then on the back of the alligators, we have Kim, who is going to be jumping from one alligator to the other. Kim the kangaroo is not going to be drawn very effectively. So I got Kim the kangaroo in there. I warned you about the drawing. And now we're going to show her jumping from alligator to alligator. So we need a vector arrow of her velocity. And so I'm drawing in the velocity arrow, and I know the speed is 7 meters per second, and I know it has some angle theta, which is what we're trying to find. So I'm going to put that as a question mark and throw in that 7 meters per second above it. Okay, so now I have my given information. The 3.2 meters are horizontal, are in the x direction. So I'm going to label them as a distance x, or dx. So I'm going to add the time. That's another piece of information from the problem. The time it takes is 0.5 seconds. Time it takes to do what? Well, that's the time it takes to go from alligator to alligator, or the time it takes to travel that x distance. So what can I do with this information? Well, I have a distance and the time it takes to travel that distance, so I can find the velocity, which would be my horizontal velocity, because this is x position. So I can find the horizontal velocity from the horizontal distance traveled and the time it takes to travel that distance. Stepping back a little farther, if I know what Vx is, then I can find V cosine theta. And V is given to me in the problem as 7 meters per second. So if I know Vx and V, I can find out the theta, which is what I'm hunting for. So let's go ahead. Vx is dx divided by time. Remember, horizontally, all projectiles have 0 acceleration, so we can use that simple equation. And now I just have to plug in my numbers to get Vx. So Vx is 3.2 meters divided by 0.5 seconds, or 6.4 meters per second. I'm going to take this information and put it elsewhere on my diagram and work on the next bit. So I know the cosine of theta is equal to Vx divided by V. So the cosine of theta is 6.4 divided by 7. Remember, 7 is her original velocity going at that vector angle. Okay, cosine theta equals 6.4 over 7. If I take the inverse cosine of the left-hand side, I have to take the inverse cosine of the right-hand side, but that'll give me that theta equals the inverse cosine of 6.4 over 7. And that's what our calculators are for. Putting that into them, we get theta equals 23.9 degrees. Voila, our answer. We are done. Thank you very much for your time.